Good evening. Let's take a look at our key for our worksheet 8.3 today, taking a look at right angle trigonometry. So when doing right angle trigonometry, you want to remember your trig rules. And if you remember SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. This rule is going to be used all throughout this whole page. The other thing that you want to make sure that you do is you have your calculator out. As you can see, I popped up my calculator here, and I'm actually in the mode of my calculator. So just to show you, I hit the mode key, so hopefully this shows up, and I want to make sure that your calculator is in degree mode. As you see, it's flashing there. Hit enter so to make sure that you're in degree mode, because otherwise none of your problems will match up if you're in radian mode. Angles are measured in two different ways, and all these problems you see that you're given them in degrees, so you definitely want to make sure you're in that mode. So to get us started here, I'm going to slide my calculator over here. We'll be turning it on and off throughout these problems. So when I go and do right angle trig, I always start off by locating where my angle is located. So here I have 72 degrees in the bottom left corner. Then I want to label my triangle based on where that angle is located. So the side right next to it, the angle, that's not the longest side, is the adjacent side. Straight across from the angle is the opposite, and the longest side across from the right angle here is your hypotenuse. So then I look at what information am I given, and which piece do I want to find? Well, I want to find the hypotenuse. I have the adjacent. So I ask myself, adjacent hypotenuse, if I go up to this SOHCAHTOA, that adjacent hypotenuse is cosine. So cosine of 72 degrees is equal to the the adjacent side 6 over x. So now we just need to solve this algebraically. This one takes 2 steps since our variable's in the bottom. I'm going to have to multiply both sides by x first. So the x is crossed out and it's no longer in the denominator. So I have x times cosine of 72 degrees equals 6. Divide now to get x by itself, both sides by the function cosine of 72. So when I do that, I get x equals, so I take my calculator, go ahead and go 6 divided by cosine, move this over just a little bit so that you can see it all, 72. Go ahead and hit enter, and I get my answer. Here it says 19.4, so I just want to round that to the nearest tenth. So in our particular case here, our answer would be 19.4. Since they don't give a unit, you don't have to put the unit measurement on it. All right, continuing on, number 2, same process. Notice how they give us the 73 degree angle, and they actually give us the same sides, but they flipped them down. So I'm just going to pick this up a little bit pace-wise. So here's our adjacent, here's our hypotenuse. So I now know that I'm using cosine again. So it's cosine of the angle, so cosine of 73 equals adjacent over hypotenuse. So x over 6. This one's a little bit easier when the variable's in the top. So all I have to do for this one is multiply both sides by 6. 6 is crossed out, so x equals, and I can plug that value right into my calculator. So now I'm doing 6 times the cosine of 73. So I go 6 times cosine of 73, close my parentheses, hit enter, and if I round this 1.75 to the nearest tenth, the 5 causes the 7 to round up to 8. So we would say that x equals 1.8. All right, continuing on. Same process, pattern all the way through. It's just making sure we identify the right trig function throughout. So on this one, across from 24 is the opposite side. Next to, but not across from the right angle then, is our adjacent. So I look up top, and that goes with TOA. So I know it's going to be tangent. So tangent of my angle measurement, 24, is equal to opposite x over hypotenuse, 12. So on this one, we can just multiply both sides by 12. So I have x equals, and I can go ahead and plug this into my calculator, 12 times tangent of 24. So 12 times tangent of 24. Go ahead and hit enter, and I get rounding. The 4 says keep the 3 as a 3, and I get x to be 5.3. Okay. Moving right along, number 4. We take a look here, done exactly the same way as number 3, it's just a different angle measurement. Here's opposite, here's adjacent. So again, we're using tangent, it's just now tangent of 37. So on this one, tangent of 37 is equal to x over 12, or I should say multiply both sides by 12 to clear out the denominator. 12's cross out, so x equals, plug this one in our calculator, so we're going 12 times tangent of 37, and we get 9.04, which we would round this to 9.0. It's good to put the 0.0 after it because that usually tells the reader that the answer was rounded. Looks like we got one more tangent problem coming up here in number 5. So if I look here, 49 across from 45 again is opposite. Next to 49 is adjacent. So again, we're doing tangent on this one. Tangent of 49. What makes this one a little bit different, I have the top number as 14. My adjacent is x. So this one, you're going to have to do 2 steps. So you multiply both sides by x, crosses out. So x times tangent of 49 equals 14. Divide both sides by tangent of 49. So I get x to equal, so calculator time yet again. You'll see us be using this calculator quite a bit in this unit. So I'm going to go 14 divided by tangent 49. Go ahead and hit enter, and I get 12 point, and this one will round to 0.2 at 12.2. On number 6. Now we get to switch trig functions because here's our angle 51. Across from it is 14, which is our opposite. But now I have the side opposite the right angle, hypotenuse. So the one trig function we haven't used yet was sine. S is opposite over hypotenuse is what we have here. So now we're talking sine of 51 equals the opposite side, 14, divided by the hypotenuse, x. So this one's just done mathematically the same exact way as the previous one. Multiply both sides by x. So x times sine of 51 equals 14. Divide both sides by the sine of 51. And you get x. So x equals 14 divided by the sine of 51, close my parentheses, hit enter, and yep, we get 18. Oops, I apologize, I did cosine. Hopefully you go, what is he doing? Divided by sine of 51. I'm glad I caught that there. My apologies. So 18.01 or x equals 18.0. Last 2 problems on this page. So here's 63. Across from it is our opposite. Across from the right angle is always hypotenuse. So we're doing sine again. So sine of 63 degrees is equal to 16 over x. So this is exactly like number 6, just different numbers. Multiply both sides by x. So x times sine of 63 equals 16. Divide both sides by sine of 63. So x equals, calculator time, so 16 divided by the sine of 63. Go ahead and hit enter. 17.95, so this one's a fun one to round. So the 5 causes the 9 to go to 0, which causes the 7 to become an 8. So this one ends up being 18.0. Our last one. Here's our angle 15, going right across. Here's our opposite. Here's our hypotenuse. So this one also is sine, but this one's a little, well, actually no, it's done the exact same way here as our last one. So we're going to be going sine of 15 degrees equals 16 over x. So multiply again both sides by x. Crosses out. So x times sine of 16, or sorry, sine of 15 degrees equals 16. Divide both sides by sine of 15. So x equals, so 16 divided by sine of 15 degrees. And we get 61.81, so that rounds to 61.8. All right, so that finishes page 1.